Welcome to the Getting Started tutorial. In this tutorial, we set up a new project, set up an approximate camera, add photographs, mark and reference points, use a 3D viewer, add surfaces and textures, define scale and rotation, and export the model. In this tutorial, we will work through the basics of setting up and producing a 3D model in PhotoModeler. First, we will briefly describe the PhotoModeler screen and how to access the various PhotoModeler features. The standard screen consists of the main menu bar, the toolbar, and the PhotoModeler screen workspace. The various PhotoModeler features can be accessed from the main menu bar by pointing over the headings and selecting to access the pop-up list. The toolbar contains icons for easy access to the main PhotoModeler tools. In addition, the toolbar expands when using certain tools such as reference or measurement. The gray space here is the workspace where we work with photographs, tables, and 3D viewer windows. Next, we begin a PhotoModeler project by using the Setup Wizards. We click the New Project button from the toolbar. This brings up the first pane of the Project Wizard. We choose the standard PhotoModeler project type and click Next. This pane lists the steps involved in a standard project. We review and click Next. Each project requires a unit of measurement and an approximate size. We choose centimeters from the drop-down list for units and enter an approximate size of 25. We click Next and begin the Camera Wizard. The Camera Wizard helps us define the camera's characteristics for use in a PhotoModeler project. This pane asks us what type of camera we will be using. We choose New Camera as this camera is being set up for a first time for use in PhotoModeler. We click Next. We are asked for some information about the camera. This information is provided by choosing one of the methods in the list, and then following the wizard instructions, we choose the single picture method and click Next. We name our camera EOS Olympus 3040 and click Next. Here we choose the option of Yes because this camera has a zoom lens and click Next. We are warned that only one zoom setting or focal length can be used for a camera description. All our pictures have been taken with one zoom setting, so we are OK. We click Next. Here we begin the steps to determine focal length and format size. Focal length is the distance between the center of the lens and the center of the camera media. Format size is the size of the imaging area of the camera. We have already performed the steps described here. We took a single picture of a piece of paper at a 45-degree angle and saved it to disk. We click Next and browse to find the saved image. The sheet is letter size, so we leave this paper size option checked and click Next. Here we are required to adjust the corners of the rectangle so it accurately matches the corners of the paper. We click and hold the cursor over a corner point of the rectangle and drag it to outline the edges of the paper. We do the same for the other corners. We then use the Zoom In tool and the scroll bars for a closer view, and adjust the corners again so the markings are as accurate as possible. We click Next, and our camera information is displayed. The Camera Wizard has used the information we provided to estimate the focal length, format size, principal point, and to determine the image size in pixels. Next, we start the Photo Import Wizard. We click the Add Remove Images button to bring up the Photo Import dialog. The left side shows thumbnails of images in the current directory. If necessary, this Change Directory button can be used to browse to the correct directory where the project images are stored. We will start this project by adding 2 photos. In any project, it is a good idea to start by importing and working with 2 or 3 photos, then adding more later as needed. We select this photo with the file name box1.jpg, press the Ctrl key on our keyboard, and select the second photo box2.jpg. The selected photos are highlighted with red border. We click the Add Photos button to import the photos. We click OK, and the images are now part of the project. We click Next and review the Setup Wizard summary. We click Finish to complete the project setup stage. At this time, our project has not been saved yet. The screen title bar indicates this with the untitled description. We will now save the project. It is a good idea to save your projects regularly, especially after each stage. We select File, Save Project As, and save the project as box1.pmr. The title bar updates to reflect the saved name. Once photos are imported into a project, their photo chips appear in this section called the Photo Control Sidebar. The Photo Control Sidebar contains a number of controls which are discussed in greater detail later. It now shows the photo chips for photos 1 and 2, indicating they are part of the project. The red X in the top corner indicates that these photos have not been worked on yet and contain no marked points. We will now begin work on the new photographs. We open Photo 1 by double-clicking the photo chip. We can also open the photo by selecting it and clicking the Open button. The photograph opens in the Photo Modeler workspace. The title bar displays some information about the photo: the project photograph number, the current zoom ratio, the photo name derived from the image file name, and the status of orientation. Orientation will be discussed later in this tutorial. Photo Modeler has various tools that help you work with photos efficiently. The zoom tools are very useful, and you will find yourself using them on a regular basis. The main zoom tools are accessible from the toolbar. Here we will demonstrate them. The Zoom In tool is used to magnify the photo. Once the icon is clicked, the cursor changes to reflect that the current mode is Zoom In. We then click over an area on the photo, and Photo Modeler will zoom in on that section. Zoom Photo Area allows you to drag and select a rectangular area to zoom in on. The Pan tool allows you to move around the contents of a zoomed-in photograph window by clicking, holding, and dragging the position of the photo. The scroll bars can also be used to navigate to other areas of the photo. The Zoom Out tool is used to zoom out of a photo area. And Zoom to Fit returns the magnification of the photo so that it fits fully in the current window. You can also change the window size by clicking the Maximize button. The Zoom to Fit tool can be used again to fit the photo in the window. There are other zoom functions that will be described later. The common tools we use for marking data are accessed from this section of the toolbar. The first tool we will use is the Point Marking tool. This tool is used to mark individual points. We click the Point Marking tool. The cursor changes to show an X with a small dot on the end. The dot is where we will actually be marking the points on the photos. On this photograph, we will model the shape of the box by marking the corners. We mark this top corner by moving the cursor over so that the dot matches the corner, and then click the mouse. A mark will then appear indicated by a small X. This marked information is what Photo Modeler needs to produce 3D results. We mark another individual point on this back corner of the box. Next, we will connect the 2 points with a line. The Line tool can be used to connect individual points with lines, and it can be used to mark successive points which are then automatically connected with a line. For an object such as a box, this tool is very useful. We click the Line tool from the toolbar, and the cursor changes to reflect that we are in line mode. We click over this existing marked point. Photo Modeler snaps to this point and does not create a duplicate. As we move the mouse away, we can see that the point has a line attached to the cursor. We move over to the second point and click again. A line connects the 2 points. We will use the Line tool to continue modeling the box. We mark along the corners of the box, and the points are automatically connected by lines. As we mark this point and connect to this top corner, this ends the current path of successive points along the outline of the box. We need to mark this point down in this corner, but we don't want the line attached from the last point. We end the current line by right-clicking and choosing End Draw, or we can just press the Escape key. We then start a new line from this point and continue marking. We complete the outline by connecting lines where necessary. Next, we will examine our marked points to see how well they are positioned and make improvements where necessary. It is important to mark points accurately in order to achieve reliable results. We use the Zoom In tool for a closer view of the points marked in this section of the box. The zoomed-in view reveals that the point positions need some improvement. We click the Select tool and select this point. A selected point will be highlighted in red, and information about the point will appear in the status bar. To adjust the position of the point, we click the mouse and hold, then drag it to a better position. We do the same for this next point. As we drag, we notice that the lines connected to the point move along as it is repositioned. We use the scroll bars and pan tool to navigate to other areas of the photo and adjust the remaining points. Next, we will do the markings on Photo 2. We double-click on Photo Chip 2, maximize the photo window, and click Zoom to fit. We will mark all the points on Photo 2 using the Line tool. We start marking the points along the outline of the box. A shortcut that is useful when using the Line tool is to click on existing points as you mark in a path. Since Photomodeler snaps to the point and does not duplicate, you can remain in line mode and continue to model the outline without having to end draw and begin a new line. Next, we will adjust the point positions using the Alt key Zoom tool. By pressing the Alt key, this function zooms in on a rectangular area where the mouse is. With the mouse over this corner, we press and hold the Alt key. The zoom window appears, and we are able to select and adjust the point. When finished moving that point, we let go of the Alt key, move the mouse over, and start again on the next point. We use the Alt key Zoom tool to help adjust the remaining points on Photo 2. This tool is convenient because we do not have to zoom in and out or move around a photograph to get the view you need. In addition, we remain in whatever mode we started in. Alt key Zoom does not affect the mode. For example, in this case, we are using Select mode. If we're using one of the zoom tools from the toolbar, we would have had reactivated Select mode after each time we used a zoom function. With the photos marked, we are ready to move on to the referencing stage. First, we select Windows Tile and Windows Zoom to fit all. Examining the photos, we see the photos are marked with point and line data. At this point, though, Photomodeler does not know that this point on Photo 1 and this matching point on Photo 2 are the same. The process of matching points across photographs is called referencing. We will reference the points using referencing mode. To start, we click the Reference Mode button on the toolbar. The toolbar expands to display icons for extra features used during referencing. The source and destination photo boxes display the current set of photos used for referencing. The source photo is always displayed on the left side of the screen and is the photo where you select points to be referenced from. This is displayed in the photo title bar. The destination photo is on the right side. This photo is where the selected points are matched up to. To begin referencing, we select a point in the source photo, and it is highlighted in red. We then move the cursor over to the destination photo. There are two changes that are immediately noticeable. First, on the source photo, the selected point is highlighted in yellow, and its point ID number is displayed. This indicates that Photomodeler is prompting us to reference this point. On the destination photo, the cursor changes to the referencing cursor, a double X with a dot. To reference the point, we move the cursor to the matching point and click down. The point turns yellow to indicate that the point has been referenced, and the cursor changes to the crossed-out circle, called the No Action cursor, which tells us the selected point in the source photo has been referenced. To reference the remaining points, we will do multiple points in the same session. We make Photo 1 the active window by clicking on the title bar. We then select Edit Select All Marks Objects in the active view. This highlights all the points in the source Photo 1. We move the cursor over to the destination photo. Again, the next point to be referenced is the highlighted in yellow in the source, and we move the mouse over and reference the matching point. A rubber band line is attached to the cursor, assisting us in determining where the matching point is based on the connected lines in the source photo. Source photo automatically highlights the next selected point to be referenced. The next point cannot be seen in the destination photo. We can skip it by right-clicking and choosing Skip Object, or by pressing the Escape key. Once we have referenced all the selected points, the No Action cursor will appear. With the two photos marked and referenced, the next step is processing the project to produce a 3D result. We click the Process icon to open the Processing dialog. The Processing dialog box displays some project information. On the left side, there is some explanation about what will happen during processing. There are two steps that processing does in a normal project. Orientation is the process of determining the camera's positions and angles in 3D space where the photo was taken. At this point, the photo titles bars indicate Not Oriented. Only after a successful process will Oriented appear in the title bar. During the 3D Global Optimization stage, the process information is refined and errors are reduced to produce the best quality result based on the inputted data. We click Process, and the progress bars indicate that PhotoModeler is doing its calculations. For small projects such as this, processing is very quick. A successful process is indicated. The total error bar provides some indications of how well the project processed. This will be discussed in more detail in later tutorials. We click OK to close the processing dialog. The title bars in the two photos now indicate that they are oriented, meaning PhotoModeler now knows where the camera was when the photos were taken. The photo chips also now have a camera symbol in the top corner, also an indicator that the photos have been oriented. To display the results graphically, we open a 3D viewer. We click the 3D viewer button from the toolbar, and the 3D viewer options dialog is displayed. We will leave the default display options of points and lines and click OK. The 3D viewer window opens and displays the result of our model so far. The shape of the box looks correct and in line with what we marked on the two photographs. We use the 3D viewer controls to study the model. We click and hold on the Rotate tool and move our mouse to spin the model in any direction. The Zoom tool allows us to move the model in and out. And the Pan tool is used to move the model within the 3D viewer window. We study the general result of the model and it looks to be in good shape. We click the Options button to bring the Options dialog back up. We select Camera Stations. This provides a visual of the camera positions and angles. We click OK, then Reset, and the stations are displayed. We can see the results of orientation by viewing the two locations of the cameras relative to the box. We select this camera station, and its station ID is indicated in the status bar. This is Camera Station 1, which represents the position of the camera when photo 1 was taken. Station 2 represents the camera position when photo 2 was taken. We use the 3D viewer controls for different views of the camera station positions. At this point, our box model is not complete, so we will add a third photo that covers a different view of the box. First, we will click the Save button on the toolbar to save the project in its current state. We close the 3D viewer, then right-click on one of the photo chips in the Photo Control sidebar, and choose Add Remove Photos. We can also access this through the File menu. This brings up the Add Remove Photograph dialog box, which we saw earlier in the Setup wizard. Photos can be added and removed at any time during a project. We select this photo chip from the left and import it into the project by clicking the Add Photos button. We click OK, and the new photo appears as Photo 3, with the red X indicating it contains no marks yet. We'll go straight into referencing points onto Photo 3. We click the Reference Mode button, then select Photo 3 from the Destination Photo list. Photo 1 remains the source photo. We'll click on the Photo 1 to make it the active photo, and select all the points by pressing Ctrl and A on our keyboard. This is a standard shortcut for Select All. The selected points highlight in red. We move the cursor over to photo 3 and begin referencing the points. We mark the points as prompted by the yellow highlights in the source photo. This first highlighted point cannot be seen in the destination photo. To skip a point that we can't see, we click the right click and choose Skip Object or hit the Escape key. We can then continue referencing points. We use the rubber band line to assist in determining where the points match up. Once we have marked all the selected points, the cursor changes to the No Action cursor. There is still a corner to be marked in photo 3, but it cannot be seen in the current source photo. We select photo 2 from the source photo list, select that point, and reference it to photo 3. We use the line tool to connect these 2 points. Next, we will go back into select mode and adjust the positioning of the new points in photo 3. Using the Alt Zoom tool, we adjust the points. At this point, we can see that photo 3 has not been oriented. We will process the project again to include photo 3 as an oriented photo in the project. We click Process from the toolbar. The steps indicate the processing will orient the new photo. We click Process. PhotoModeler quickly processes the project and a successful result is indicated. We notice that the title bar now says Oriented and the photo chip displays the camera symbol. To check the results, we open a 3D viewer. We will leave the options of points, lines, and camera stations on and click OK. Using the 3D viewer controls, we can see the positions of the 3 camera stations. To get a better view of the box, we open Options and turn off camera stations and click OK. We use the 3D viewer to study the shape of the 3D wireframe of the box that we've created. Next, we will make the model more complete by adding surfaces to it. Surfaces are 3D objects and will only appear in 3D viewer and table windows, but not in photo windows. In the 3D viewer options, we choose the Surfaces option, leave Shaded Mode on, and click OK. Now once we added surfaces, they will automatically appear in our 3D viewer window. We select Surfaces from the toolbar. This brings up a menu that lists the various surface tools that we can use. There are 8 different ways to create surfaces in PhotoModeler. In this project, we will use the Boundary Patch mode. Boundary Patch mode lets you define a surface by selecting 3 or 4 lines or curves. The cursor changes to reflect that we are in Boundary Patch surface mode. We select these 3 boundary lines on the face of the box. And a surface is created that covers the area defined by the selected boundary lines. To tell PhotoModeler that the surface is finished, we right-click and choose Finish Surface. We rotate the model so that we can get a better view of the top of the box. We use the Boundary Patch Surface tool to create a surface covering this area of the box. We can also create the surfaces on a photograph. On photo 3, we click on these 3 boundary lines to create a surface. Notice that the lines are highlighted with a thick white line to indicate they are being used in surfacing. As mentioned, the completed surfaces will not appear on the photos, but only in the 3D viewer and table windows. We finish surfacing the remaining sides of the box in the 3D viewer. We open the 3D viewer, turn off points and lines, and click OK. We get a view of the surfaced box. We expand the size of the 3D viewer window by clicking and dragging a corner of the window. Surfaces can be selected just like other objects, such as points and lines. We use the Select tool to select the surface. It highlights in red, and some information about the surface appears in the status bar. It tells us that the surface has surface ID number 2, it is in 3D, it is using the material surface default, it is using the default layer, and it is made up of 2 triangles. Each project contains 2 default materials, the default white material and the default surface material. PhotoModeler allows us to create other materials for use with surfaces. One of the advantages of using PhotoModeler in photographs is that we are able to extract textures from the photographs and map them onto the 3D model. To show photo textures, we click on the 3D viewer options and choose Fast Textures from the drop-down list associated with surfaces. We click OK, and PhotoModeler maps the textures onto the 3D model. We'd rotate and study the textured model. Although the model looks relatively good, there is some obvious distortion in the textures. This distortion is due to perspective from the angled photographs. To achieve higher quality textures, we go back to the 3D viewer options and choose Quality Textures, and click OK. These textures take longer to create, but provide higher quality rendering of the object. The resulting textures no longer show the distortion and line up properly on the box. Next, we will add a scale and rotation to the model. First, we close the 3D viewer, maximize Photo 2, and click Zoom to fit. From the Project menu, we select Scale Rotate to bring up the Scale Rotate dialog. We click on the Scale tab. Here we will add a known distance between 2 points in the project. Once we do this, the rest of the project is scaled so the measurements represent its actual dimensions. We move the dialog box so we can see more of the photo window. We select this line, or we can select the 2 points individually, and then enter the exact known value in the scale distance box. We enter 25.4 centimeters and click Define. The selected points are then highlighted in green and have an S attached, indicating that these are the points used to define scale. If a scale is not added to the project, you cannot use it for accurate measurement, or your exports will be the wrong size. In some cases, the exact absolute scale will not be important to your project, and you can skip this step. Next, we click the Rotate tab. Rotation defines what coordinate system a model lies in when viewing in the 3D viewer or when exporting to another program. Without this rotation step, the PhotoModeler model will have an arbitrary rotation. We need to define 2 of the X, Y, or Z axes to set a rotation. The third axis will be automatically calculated based on the other 2. To define the X-axis, described as a horizontal axis left to right, we select these 2 points along the bottom of the box using Select and the Shift key. We click Define. The 2 points are then highlighted in red with X1, X2 attached to indicate these are the points used to define the X-axis. Next, we define the Z vertical axis, bottom to top, by selecting these 2 points and clicking Define. We click OK to complete Scale and Rotate. To view the results, we open the 3D viewer. Now that we have a rotation defined, the model opens in the 3D viewer with a straight-on view of the top of the box. We use the viewer controls to zoom in. We then click Options and Settings and choose the front view from the Reset Direction options. We click OK, and the model appears straight on from the front. The rotation gives the model an alignment with the standard coordinate system, which is important for the next stage, which is exporting the model for use in another program. First, we click the Save button from the toolbar to save the project. Remember, it is important to save the project often. Next, we open the Export dialog by selecting File, Export Model. Photomodeler exports in a number of different formats, including DXF for CAD and 3ds for 3ds Studio. In this case, we will export as 3ds. Photomodel allows you to export different data from your model depending on which format you choose. 3ds only allows exporting of surfaces and cylinders. There are no cylinders in this project, so only surfaces will be exported. Photo textures can be exported with the surfaces. Here, we are given a number of options for exporting textures. We choose Quality Textures, High Quality JPEGs for texture map file format with a 1024 by 1024 size. We click OK and export the model as pmbox.3ds. We click Save, and the textures are created. The exported data can be imported into a 3D graphics program for further work or rendering. This completes the Getting Started tutorial. We have completed a 3D model of a box from beginning to end, working through the stages of setting up a new project, setting up an approximate camera using the single sheet method, adding photographs, marking and referencing points, using the 3D viewer, adding surfaces and textures, defining scale and rotate, and exporting the model.